Imagine a cosmic object so dense, so unfathomably powerful, that it warps not only space but also time itself. A place where the rules of reality as we know them begin to blur. Black holes have fascinated scientists for decades, appearing at first as invisible monsters lurking in the fabric of the universe, detectable only through their gravitational grip and the radiation emitted by matter spiraling into them. But recently, astronomers have witnessed a behavior from a black hole that defies every expectation. Something no one has ever seen before. Something that forces us to rethink not only astrophysics but also our own understanding of perception, adaptation, and the limits of observation. When a black hole does the unexpected, it is not merely an astronomical curiosity. It becomes a mirror for the ways our own minds navigate the unknown. This is a story about extremes, about boundaries, and about what the cosmos can teach us about the very nature of thought itself. To understand why this recent observation matters, we must first appreciate what a black hole is, not just physically but conceptually. A black hole is the ultimate expression of concentration, a point where matter collapses into a singularity, and gravity becomes so intense that not even light can escape. From a psychological perspective, black holes embody paradox. They are invisible yet detectable, destructive yet integral to the cosmic ecosystem, and their behavior challenges our cognitive comfort zones. Observing one behave in a way never seen before is analogous to experiencing a moment of cognitive dissonance. Our brain anticipates the familiar patterns, yet reality responds with novelty. Just as our neurons continuously adapt to new information, our understanding of the universe must remain flexible, embracing surprises that provoke both awe and critical inquiry. The discovery in question involves a supermassive black hole in a distant galaxy, millions of light years away, which exhibited a series of rapid, coherent flashes of energy unlike any previously recorded. Traditional astrophysical models predict that black holes consume matter in a relatively steady fashion, occasionally emitting X-ray bursts when falling material accelerates and heats up. What astronomers observed, however, was more akin to a complex signal pattern, a pulsing energy waveform that appeared organized. Rhythmic, almost like the black hole itself was communicating through its activity. It is tempting to anthropomorphize these phenomena, to imagine consciousness in the void. But what is truly remarkable is how such events mirror the dynamics of neural networks, both in pattern and consequence. In the brain, neurons fire in oscillatory sequences, creating rhythms that govern attention, perception, and learning. In a black hole, matter and energy oscillate in patterns that hint at underlying structure, at constraints we are only beginning to model mathematically. In essence, we are seeing cosmic neuroplasticity, a massive system adapting, surprising us with emergent behavior, reminding us that even the most extreme environments obey principles of order and change. From a cognitive science perspective, witnessing such an event triggers a cascade of reactions in the human brain. The limbic system responds with awe. The prefrontal cortex attempts to make sense of the novel pattern. The insula signals the discrepancy between expectation and perception. Just as our neurons strive to form meaning from chaotic inputs, astronomers and theorists are forced to revise their models to explore new frameworks for understanding. This interplay between prediction and surprise is central to how intelligence operates, whether in humans or in observing the cosmos. We have evolved to detect patterns, to anticipate threats, to learn from anomalies, and in this sense, the black hole becomes a teacher, showing us the limits of our assumptions and the flexibility of adaptation. Neuroplasticity, the brain's capacity to reorganize itself in response to experience, provides an elegant metaphor for what we witness in the black hole's unexpected behavior. Just as repeated stimulation can strengthen neural pathways, novel astronomical events strengthen the frameworks of understanding within scientific communities. These flashes are not mere light, they are data, signals that provoke thought, ignite debate, and compel refinement of theory. The brain and the cosmos are intertwined in this dance of adaptation. One encodes, predicts, and learns. The other generates, surprises, and challenges. Both remind us that stability is an illusion, and that at the edge of knowledge, the unexpected is not an obstacle but an invitation. The implications extend beyond astrophysics. Consider the psychological parallels. Human perception is constrained by the boundaries of expectation. Our brains constantly filter incoming stimuli, privileging information that aligns with prior knowledge, discounting anomalies as noise. But when confronted with a truly novel event, a black hole pulsing in unforeseen ways, a sudden shift in social dynamics, or an unpredictable outcome in one's personal life, our cognitive systems are compelled to expand. Stress responses activate, yet adaptive mechanisms engage as well, allowing us to assimilate new patterns, to rewire our understanding, to integrate the unexpected into coherent models of reality. Here, cosmic phenomena illuminate fundamental principles of cognition. Novelty is not chaos. It is an opportunity for growth, for resilience, and for expanding the scope of what is possible. Biologically, one might view the black hole as an extreme example of a self-organizing system. In living organisms, energy flows through networks of cells, signaling pathways and biochemical gradients, sustaining structure while allowing for adaptation. The black hole, too, is a network of energy and matter, dynamically interacting, exhibiting emergent phenomena that arise from the interplay of fundamental forces. The analogy is striking. The human brain is a complex system with constraints and flexibility. The black hole is a cosmic system with constraints and emergent flexibility. In both cases, order emerges from chaos, patterns arise from interactions, and the observer is compelled to confront the limits of comprehension. Quantum mechanics offers an additional layer of insight. Just as particles exist in superpositions until measured, the behavior of a black hole may be contingent upon the interactions of countless probabilistic events. When astronomers detect these coherent energy pulses, they are collapsing a wave of possibilities into an observable pattern. Much like measurement in quantum experiments selects a definite outcome from a cloud of potentialities. This parallel invites us to consider perception itself. Our brains are constantly reducing uncertainty, predicting outcomes, and resolving ambiguity. Yet the universe continually presents scenarios that challenge these resolutions. The black hole, in its paradoxical flashes, is a cosmic demonstration of uncertainty, an order coexisting, a reminder that reality is not a static ledger but a dynamic interplay between possibility and observation. One of the most fascinating aspects of this discovery is the twist, inherent in both the physics and the psychology of observation. The black hole's behavior, initially perceived as anomalous or even problematic, is in fact a natural consequence of its environment, a sophisticated balancing act of gravitational forces, magnetic fields, and relativistic dynamics. In this, we see a striking analogy to human stress responses. When we encounter threats, our instinct may be to resist, to perceive limitation as weakness. Yet neurologically, stress triggers protective mechanisms, reorganizes neural pathways, and enhances resilience. The unexpected pattern of the black hole is not a malfunction. It is a form of self-regulation. Similarly, what we initially interpret as cognitive or emotional limitations are often adaptive strategies, evidence of the brain's capacity to optimize survival and understanding in uncertain conditions. Suffering, in this context, can be reframed as guidance, disruption as adaptation, and the extreme as an opportunity for insight. Philosophically, the implications ripple outward. If a black hole, a singularity where conventional laws of physics collapse, can exhibit structured, coherent behavior, what does that suggest about the nature of the universe itself? Perhaps order and chaos are not opposites but complementary dimensions of a deeper reality. Just as the brain integrates conflicting stimuli into a unified perception, the cosmos integrates extreme forces into emergent phenomena. Observation, whether neurological or astronomical, becomes an act of co-creation. The observer shapes understanding, and understanding shapes perception. In this sense, learning is cosmic. Cognition is universal. The boundaries we perceive, whether in the brain or in the universe, are invitations to expand, to probe, and to embrace the unknown. Consider also the role of energy as a unifying metaphor. In neuroscience, thoughts are patterns of electrical and chemical energy traversing networks of neurons. In a black hole, energy is concentrated, transformed, and sometimes released in unexpected ways. Both systems are defined by flows and interactions, by feedback loops and emergent consequences. The human mind and the black hole are, in a poetic sense, analogous, nodes within larger networks, channels of energy and information, systems that adapt and respond to stimuli, both internal and external. Observing one enriches understanding of the other, and recognizing this interconnectedness fosters intellectual humility. The universe is not merely out there. Its dynamics resonate with the processes within us. The revelation of the black hole's unprecedented behavior also prompts reflection on the nature of limits. In physics, a singularity represents a boundary beyond which classical equations fail. In neuroscience, limits are imposed by neural architecture, sensory thresholds, and cognitive biases, yet in both cases, boundaries are not static. They are fluid, extendable through insight, technology, and adaptation. The pulses observed from the black hole force a re-evaluation of previously assumed limits, illustrating that even in systems governed by extreme constraints, novelty and flexibility are possible. This challenges a fundamental assumption that the unknown is unreachable. Both the cosmos and the mind demonstrate that boundaries are as much a matter of perspective as of objective measure. We can even draw a metaphorical bridge to consciousness. The rhythmic energy emissions resemble oscillatory neural activity patterns that encode information, create coherence, and enable complex functions. If we think of consciousness as emergent from the integrated activity of the brain's networks, then the black hole's energy pulses serve as a cosmic echo of emergent order from a vast and incomprehensible substrate. There is a humility in this realization. The universe operates through mechanisms that are both profoundly alien and curiously familiar. By studying the cosmos, we not only map physical realities but also gain mirrors for understanding cognition, adaptation, and the subtle interplay between expectation and surprise. Furthermore, this discovery illuminates the value of observation itself. Human perception is not passive. It is an active engagement and interpretation of signals filtered through neural architecture, prior experience, and cultural frameworks. Likewise, astronomers do not merely record data. They interpret patterns, apply theoretical models, and predict outcomes. The black hole's behavior challenges these predictions, reminding us that the act of observation is as much about questioning assumptions as it is about recording phenomena. In cognitive terms, this is a lesson about humility, curiosity, and the necessity of flexibility. The universe is a laboratory of adaptation, and our minds are instruments finely tuned to learn from the unexpected. As the pulses continue, scientists debate their origin. Are they the result of magnetic reconnection events, exotic particle interactions, or a heretofore unknown relativistic effect? Each hypothesis, while grounded in rigorous physics, points toward a larger truth. Complexity in extreme environments often manifests as patterns that appear almost intentional, yet emerge naturally from fundamental laws. This duality mirrors our own experience. Behaviors that seem deliberate or meaningful may arise spontaneously from underlying processes, whether in ecosystems, economies, or the brain itself. Recognizing the emergent nature of complexity fosters both scientific rigor and philosophical reflection, highlighting the interplay between determinism and creativity, structure and freedom, order and surprise. The psychological resonance of this discovery cannot be overstated. Observing the unexpected triggers cognitive processes related to curiosity, learning, and meaning-making. Novelty stimulates dopamine pathways, enhancing motivation and memory encoding. The black hole, in this sense, is not merely an external phenomenon. It is a catalyst for internal neurochemical and cognitive dynamics. The universe, in revealing its unexpected behaviors, becomes a teacher, shaping neural circuits and guiding attention, inviting us to expand our conceptual frameworks. This is the essence of intellectual growth, to confront the unfamiliar, integrate it, and emerge with an enriched understanding of both external and internal realities. In the end, the black hole teaches a profound lesson about resilience and adaptation. Systems under extreme conditions, whether cosmic or neural, do not merely collapse under stress. They reorganize, exhibit emergent patterns, and sometimes reveal previously unseen capacities. The very act of encountering the unexpected strengthens networks, whether in the brain or in scientific knowledge. Limitations, anomalies, and surprises are not failures but mechanisms for evolution, learning, and insight. Our perception of weakness may obscure hidden strengths. Our assumptions about boundaries may overlook latent possibilities. Just as the black hole pulses with organized energy in defiance of expectation, so too does the human mind possess capacities that manifest most vividly when challenged. As we reflect on this discovery, we are invited to consider deeper philosophical questions. What does it mean for a system to adapt? How does perception shape reality? To what extent do boundaries exist independently of observation? The black hole is more than an astronomical curiosity. It is a lens through which to explore cognition, resilience, and the dynamic interplay of order and chaos. It reminds us that the universe is not static, that patterns emerge from complexity, and that the act of understanding is inseparable from the act of observation. In conclusion, the unprecedented behavior of this black hole is not only a landmark in astrophysics, but also a mirror for human cognition and adaptation. It exemplifies the interplay between expectation and novelty, constraint and flexibility, chaos and emergent order. Observing it challenges our assumptions, stimulates our neural networks, and invites philosophical reflection on the nature of boundaries, perception, and resilience. It teaches us that the unknown is not a threat but an opportunity, that the extreme can reveal hidden structures, and that both the universe and the mind are capable of astonishing flexibility and creativity. Every pulse, every flash, every anomaly is a reminder that the cosmos is an active participant in the ongoing dialogue between observation, understanding, and imagination. What other surprises might await us, both in the universe and within our own neural architectures? How might this knowledge reshape the way we think about limits, adaptation, and the potential of conscious exploration? The black hole has spoken in its enigmatic, rhythmic pulses, and the invitation is clear: to watch, to wonder, and to engage fully with the unknown. If this journey through the extraordinary has expanded your sense of curiosity and awe, make sure to like this video, share your thoughts in the comments, and subscribe to MindSpark Science for more explorations where the boundaries of the mind meet the frontiers of the universe.